Hello everyone, it is time for this week's live stream, and we have a special guest that will be joining us in just a few minutes. He is already online, but I have some business I need to take care of first of all. So I wanted to kind of catch you up. Last weekend was Aquashella here in Dallas. I had a great time. I came home with some new frags. I've been sharing a couple of those images on Instagram and on Facebook. So if you haven't seen those yet, kind of follow my social media. It's always at MeLovesReef. I also have something in the works for the future that you will be looking forward to that involves an aquarium. So you'll be seeing that soon. I want to remind you that Reef Trace is a great app to keep track of your water parameters. It is literally the app that I do use for my aquarium needs. Plus, I love the notes section. And they've enhanced it. I was actually poking around in there today trying to figure out what all they can do. It's got some really cool new features. So if you haven't got Reef Trace for your iOS or Android phone, you should get it. One of the big things I do when people mention they're looking for a local fish store is I said, do you have Reef Trace? Because you can literally open up the LFS Finder and it'll find anything within 45 miles of your location. So if you don't have that, you need to get it. The reef update, I pulled out a ginormous coral out of my reef last Sunday morning before I had to rush to Aquashella. And it was so big, it was like the size of a pizza. It was a giant chalice that had been growing up the walls of the tank. Those pictures and images were shared. I don't know when I'll share it on YouTube, but I wanted to tell you about it so it would give you a reason to go look for it. But it was crazy, and it all came out in one piece, fully intact. I didn't break it, and my buddy was working under the tank, bagging up corals. And I said, can you come here, please? As I was holding this giant thing. And I said, and do you have your phone on you to take a picture? And his reaction when he came to eyeline with me was like, holy crap. He could not believe what I lifted out of my reef. And I'm sure some of you will even say that coral is bigger than your entire tank. And that's possible because many of you have nanosystems. I've got something important I need to mention. My friend Cruz Arias is looking for a kidney. And he is desperate. He has been fighting kidney disease for about 11 years. He's now on hospice. He is getting like some kind of super dialysis 5 days a week that's even longer than the normal dialysis. He's in constant pain. He's looking for a living donor. I'm not asking for money. I'm asking you to look at the link that's in this video's description, click it, see if you possibly are a match, if you are willing, if you know someone that might be willing, if you just want to spread that link around, the more people we can reach, because he's been on this wait list for so long, but he's gotten so weak now that they're even concerned about doing surgery, so he's still looking for help. So if you would like to spread the word so we can reach more and more people, that's the best we can do. At least we're doing something because, he's 46, married, children, and doesn't deserve this at his age. So I wanted to bring that up. In 2 days, it will be Caitlin's birthday. We lost her a couple of years ago, so I'm going to be obviously mentioning her in a couple of days. And her reef tank, the Caitlin's Reef, is also turning 1 year old, basically on the same day. I set it up like mere hours before, so I'm just going to say her birthday is the anniversary date of that aquarium. And it needs some deep cleaning right now. I got to do a sand bed vacuuming. I've got to change some water and then, kind of clean the pumps and filters and everything because it's getting a little overrun with algae that I don't like. But once it's pretty, I will be sharing. So I've got a little bit of time to do that before the official anniversary date. So I wanted to just let you know that's coming up in case you were wondering. I'm sure that's the first thing when you woke up today is like, when is Caitlin's tank turning 1 year old? We're there. And little Flare is looking so beautiful. I posted some recent pictures of how nice that Japanese pygmy angelfish is looking. That thing was captive bred by a friend of mine in Hawaii. I'm grown from eggs and sperm. I mean, I just love that there's a backstory and it's not just some random fish out of the ocean. Okay, we're going to bring on Andrew now. If I can click the right button. Gee, I hope it's this one. It worked, and let me turn on his audio. So hopefully you guys can hear him too. He's moving. That's a good sign. Can you hear me, Andrew?
Yeah, I can hear you.
Okay, good. We are going to talk about cyanide-caught fish. And you know what? I want to go I want to go super stupid with you. I just want to say, first of all, where does cyanide come from? Is it a berry you mash? Is it a flower you rip apart? And how can people, I mean, they're not getting it from Amazon, right? I mean, where is this stuff and why does it exist? And why would someone think squirt that at fish in the ocean?
Yeah, so that's actually a really good place to start. But before we start, can I ask you? The screen has me flipped, flipped backwards,
It
which
looks
is
like you're
kind of
flipped, but it's actually the correct
yeah.
way. I
All
think.
right, okay.
I think.
That's
I get that.
strange.
I had that happen to me when I was on someone else's thing, but then it
Yeah,
looked
yeah.
right on YouTube. So let me see
So
your shirt. Let me see if I can read your shirt. Yeah,
yeah,
it's the
you
right way.
can't you? Yeah, yeah, okay. All right, okay. Um, so I think it's a really really good place to start. Cyanide is fairly heavily utilized chemical in industry. Actually, it's a pretty good reactant compound. It's used heavily in mining operations. Gold mining and other activities use cyanide a lot. So it's readily available through various industries. Obviously, you can't go into Amazon and get it. Um, and the cyanide we order, comes in very hazmat labeled boxes, but it is available fairly. It's usually controlled when it's sold, but it's not hard to get. Um, People know what cyanide is because it's such a deadly toxin, right? Such a deadly poison. So pretty much everyone knows what cyanide is. Cyanide is naturally derived in a lot of plants. Actually, plant seeds actually have a lot of cyanide in them to keep animals from eating them, and so all animals generally are exposed. We are exposed to cyanide constantly through our food sources.
Wow.
You'll have some background level of cyanide intake. If you're a smoker, you're actually taking in a good bit of cyanide
Okay.
all the time from cigarettes. And then why would somebody squirt this in front of a fish's face, right? Uh,
Yeah.
that started actually, believe it or not, well, I mean, I think it makes a lot of sense actually. It was a scientist in the United States that in the late 1950s, early 1960s that came up with a method to prepare aquaculture ponds for new fish. So they wanted some way to basically kill everything in the pond, and then in a day or so, the pond would be ready for new fish. And cyanide actually is quite good. So there was a paper published about the
Wow.
utility of cyanide in the 1950s, 1960s, and then shortly thereafter. And it's hard to know if there's a correlation between that research and then it's showing up in the Philippines, but then it started showing up in the aquarium trade, you know, in that decade-ish, 1960s, 1970s.
Yeah.
And then, it had been a real problem into the 90s. It's still a problem, but it had been really an epidemic in the 80s, 70s, 80s, and 90s, early 90s, and it's less of an epidemic now, but it's still quite a problem.
You know, the only time I ever heard of cyanide was probably watching a James Bond movie or one of those movies where they say it's in the tooth and they're going to break it to commit suicide. You know, the cyanide capsule. And I mean,
Yeah, sure.
I just heard it's like for the bad guy, or, to escape going to prison kind of a thing. You just kill yourself. But, this whole process of, I mean, where are the divers, the fishermen, where are they getting it? Because here's the thing, I'm not trying to be paranoid, but I was thinking if you knew, let's say there was a guy named John, and he is a known fisherman. He's really good at catching fish, like too good. And all his other buddies never catch nearly as many fish as he does. And then, they find out John's squirting cyanide at them, right? So why wouldn't then, where he takes a fish, the people that run the business say, yeah, we're not buying from you anymore because you are literally poisoning fish? Why wouldn't they just rule John out and only use the rest of the fishermen and not take the risk of sending a fish that's dying and decaying on the way to whatever country it's going to?
Well, yeah, I think that comes down to it's hard to find from the United States or in Europe or in the source countries. It's really hard to know where your fish, if you're a store or you're a hobbyist, particularly, where your fish were, who collected your fish, right?
Yes.
The importers have a little bit better insight. In many cases, they'll, depending on the country, um, they'll know the collection stations and the locations of those fish. But in some countries, the Philippines and Indonesia, is a lot harder to get what's called traceability or
Mm.
understanding exactly where the fish came from. There's a lot of lot of little chains in the
Yeah.
node. And I talk about this in some of my talks. It's like your clothing. Like, you have no idea who made that T-shirt you're wearing,
You're right.
right?
Yeah.
And I promise you, the person who screen printed it didn't know who made it either, and the
Yeah.
person who bought it before that didn't know. So I think it's really understandable to think that hobbyists and stores, even, and some importers, are going to have trouble knowing exactly the origins of their animals. There's not a lot of traceability.
Yeah.
The importers have done, some of them have done a lot of work to get to where their fish are coming from, and trying to add traceability into the system. And you can see, there's QR codes in the marketplace to actually help you understand where things are coming from that are
Mm-hmm.
there to be traceable. People sell fish of certain origins, and if you look at the map that you've got up above your head there, the Pacific Islands are a really good source of origin for sustainably caught fish. And so you'll often see labels of country of origin with fish, either a Fiji this, or a Tonga, or something from Kiribati, or some Australia. So there's ways to kind of understand where your fish are coming from and rule some of these destructive fishing methods out. But in mostly in Indonesia and the Philippines, fish are aggregated from a fisherman into a middleman.
Mm-hmm.
And Rhett Talbot has actually written quite a bit about this, and had spent quite a bit of time over there. And the middlemen, or the exporters, are usually supplying the fishermen with cyanide, because and so
That's the
and
problem.
you
No more of that.
yeah,
I mean, it
so
should just stop
right.
there.
So easy to say that, Mark. So easy to say that. So, I've spent quite a bit of time in the north coast of Bali with the fishermen up there in Les Village, and some other areas. I'm headed to Jakarta in a couple weeks.
Mm-hmm.
But uh, the uh, um, the fishermen generally don't want to use cyanide, and right,
Mm-hmm.
especially if they're a little bit more educated about what's happening. And there's some really, there's quite a bit of a documentary evidence in the literature about some efforts that was made in Les Village, to kind of that whole 40-kilometer area or so that's fished there. The fishermen kind of, starting to observe people catching fish with cyanide in the 1980s or so, starting to use cyanide, and then realizing what it was doing to their reef, and then also what it was doing to them, right? And then getting access to
Okay, let's
nets
stop right there.
and things
Let's
like
stop right
that.
there.
Yeah,
Excellent point. So it hurts the reef too? Doesn't just stun a fish?
yeah. No, it's that we would call this a destructive fishing method because and I'm not sure how many of your list, your viewers have been to Indonesia or the Philippines, but in Indonesia particularly, a lot of the areas have been fished with they use it's called dynamite fishing. They don't necessarily use
I've heard of that,
dynamite,
yeah.
but
Right.
right, yeah. Um, so you start leveling out that habitat and taking the complexity out of the habitat and making it basically a rubble field. And then cyanide slowly kills things on the reef. So you might not kill the coral the first time or the second time, but where they're breaking the coral to get to fish and things.
Yeah.
So you can tell areas that have been fished with destructive fishing methods, and so most of it's through the food fishing, because that's a much more intense, heavier activity than aquarium fishing. But
The
so you
destruction
can
is
see
not the
these areas.
cyanide.
Well, no, cyanide fishing for food fishing is much bigger than aquarium fishing. Yeah.
All right, well,
So,
let's stop there then.
um,
I wanted to ask you the other part. You said it makes them sick too. What were their symptoms, or how did their skin
um,
burn? What's happening to
yeah,
them?
one of them, though, like you can read in the literature, some of them, and I've talked to some of them about it. Shoulders being sore, like just things about their their daily physical condition that was just
Yeah.
off, right? And when Nancy and I are in the lab, my analytical chemist colleague that we're exposing fish in the lab to cyanide, we are dolled up in all kinds of what you call PPE, or personal
Right.
protective equipment, and with fume hoods and procedures and stuff. And we kind of, we're like, wow, this is, and fishermen are out there with a squirt bottle and with a tablet. We're at much
All over
higher
their body.
doses than we're using.
Yeah.
Well, not all over, but you're in the water. And so I think, so what people need to understand is that, this problem started, in the 1960s. It was 30 years of really an epidemic. A
Yeah.
lot of hard work has been put in by people in the industry to reduce the amount of cyanide that has been
Hmm.
caught. A lot of hard work went into with some non-governmental organizations or NGOs to try to help educate fishermen and help supply alternative livelihoods and alternative fishing methods. And it's illegal in these countries. Countries have done a little better job of stepping up enforcement. So you've had progress all along, but it was a real epidemic. And the real challenge is that you can't, as a consumer, you don't know where your
Right.
fish were caught, really,
Yep.
right? And so you have no idea the sourcing of your fish. And so it's
Hmm.
hard to know whether you're buying fish that are supporting rural fisheries that are providing income into areas that are sustainable, because the aquarium industry has you know uh, arguably it's what we call a high biomass or value, low biomass, high high value fishery, where you have hundreds of dollars per kilogram of value or more for those fish,
Right.
and compared to food fish where you're getting a few dollars a kilogram, right?
Right.
So
Yeah.
so the value proposition is pretty good, and so if you're supporting sustainable fisheries, whether it's Fiji or Indonesia and sustainable fisheries, right? If you're supporting sustainable fisheries, you're supporting generally fairly rural areas that don't have an industry or a lot of employment that can just go and and it's a renewable resource, right? If you're taking care of the environment around these fish, then the fishery itself is a very renewable resource as long as the fishing's not destructive. And so it puts you in kind of a dilemma. You'll hear people talking about wanting to have all aquacultured fish because they
Mm.
don't want to have to worry about, right, where their fish come from, or contributing to the degradation of coral reefs. But and I think that the same thing goes for corals too. And we could have a conversation about that too, about sourcing on those. You're not necessarily supporting reefs by buying aquaculture fish. You might be offsetting trade a little bit, and maybe if a particular fish is over collected or has some issues, it's a good source to buy aquaculture fish. But you're not necessarily protecting coral reefs by that purchase, right? Unless
Right.
that money is going back over into the areas where these ecosystems are, and
Yeah.
supporting their economy, or supporting some restoration, or supporting something in those areas, right? So I
Yeah.
think there's a disconnect on how people view that.
Okay. So, still hung up on some of what you said before. If
Sure.
um, if they were catching fish for eating in the 70s, 80s, 90s with cyanide, people were eating fish full of cyanide. I mean, does it bake off when they're cooking and become safe? Or is it a toxic fish that people were
Um,
eating back then, and that's why we have skin
Yeah.
tags?
So, and well, that's honestly why I messaged you the other day. Um, my daughter's going to come say hello.
Hi.
That's that's why I messaged you the other day, about about hopping on to a live stream. Is I had someone message me, sent me a message and said, "Hey, I've been talking to Mark, and I'm worried about toxins being released from my fish,
Yeah.
and from being caught with cyanide, if they had, because this person didn't know where their fish were coming from, and
Right.
they were a bit concerned." Um, and and so
You're dumb.
so yeah, um, so I kind of, and so as soon as he asked that question, I realized that we really need better education and communication with the hobby about exactly what's going on here, so people can
Yeah.
understand what is happening with the fish, and what risks there are to, say, a hobbyist or consumer. I personally, I think it would be quite glorious karma if fish that were caught with cyanide had cyanide in them when people were eating them,
Hmm.
right? But that's just not the case.
Oh.
So if you, for example, we can go back to people who are smokers or eat a lot of bitter almonds or something like that, and they're naturally intaking quite a bit of cyanide.
Hmm.
You have enzymes in your body, because cyanide is always present in the environment around you. Firefighters, often are exposed to quite a bit of it from burning in buildings and things. But so you have a lot of enzymes in your body that are designed to basically detoxify cyanide,
Okay.
because it's such a dangerous compound to your
Right.
body that you have evolved. Animals have evolved very complicated enzymatic pathways to reduce that, and to basically turn it into something that's not toxic.
Right.
and they do that really quickly. So so when you expose a fish, they're basically paralyzed. So it essentially paralyzes them, and this happens to humans as well. If you're exposed to enough cyanide, it will paralyze you, so you
Hmm.
cannot move. You basically shut down a couple pathways, and you can't move.
Wow.
And then how quickly, if you recover or if you die, depends on how much of that enzyme you have available to detoxify it. So cyanide bonds to hemoglobin, which
Okay.
carries oxygen, right? It bonds and it really holds on. It really likes that a lot.
Hmm.
And so the enzyme will come in and cut that out and get that off the hemoglobin and then turn that into it's a sulfur compound, right? And it turns it into thiocyanate, which is just sulfur with CN on it or cyanide. And so how well you can do that determines on whether you live or die.
Yeah.
And so that happens really, really quickly. And I can show you some graphs and things to show you how fast that happens.
Hmm.
But it happens in fish. Now, fish are cold-blooded animals, and I think people need to
Hmm.
realize that. So, fishers' metabolism is set by the rate of the water temperature they're in.
Yeah.
We're not. We're warm-blooded, so our metabolism's pretty fixed on those things. So, but humans eliminate cyanide very, very quickly from their system. Fish a little bit slower, but still what you would call fast, right? So
Yeah.
we're talking about less than a day, and you're eliminating it. So
Oh.
so it's out of the fish. And I can, if you want, I can show you a couple of those. I can show you a graphic that kind of explain that.
Now it hurts their organs, though, right? That's why you can buy a
Yeah,
fish that's eating and swimming, and it still drops dead a little while later.
yeah, so I hear this a lot, and there's been some literature. David Bellwood, really famous coral reef ecologist, fish ecologist in James Cook University, had done. He was actually a fish hobbyist, right?
Hmm.
So in the 1980s, he actually published an article in I think TFH, maybe can't remember the magazine. Two articles where had just graduated from Bath University, undergrad university in England, and he was a hobbyist and he was buying fish that he was, and this is cyanide was a real problem back then.
Hmm.
So he got fish and then he exposed fish to radioactive cyanide in the in the lab, and so then when he got his faculty position, you could see he was still interested in this topic because he had some graduate students look at the gut, the lining of the gut, and did some
Hmm.
histology on the fish, and there was some definite damage to the fish's gut, but that generally repairs itself fairly well.
Oh.
When we expose fish in the lab to cyanide, you would never be able to tell they've been exposed if they're
Really?
alive.
Oh. Wow.
The day and a half, 2 days, 3 days after, you can't tell. You could walk in, a few hours after, you can definitely tell. Shortly thereafter, you can't. They don't eat for a few days, and then and we're giving them enough we're giving them enough cyanide to almost kill them, just to not kill them, right?
Yeah.
That's how much we're giving them right on the edge,
Right.
and then we can usually recover them all. Now, these are fish that are aquaculture clownfish that are really robust and
Yeah.
have never been, exposed to any, and they're coming from our lab, so there's no stress involved from that. But there definitely is some damage to the liver, the gut, probably the heart, and some all the kidney. There's gonna be quite a bit of damage. Now, whether the mortality people are seeing or the inability to eat is directly tied to cyanide exposure, I'm not aware of any research that's actually been done that really demonstrates that conclusively, right?
Oh.
I think what happens is I think people buy fish and they don't survive for some reason, or they don't eat, and they make a decision that there must have been something wrong with that fish, which they should make that determination, right? That if the fish wasn't eating, or just kind of just failed to thrive, really, there's something wrong with the fish, right? Or the sourcing of the fish, more per
Yeah.
se. um, Now, it doesn't have to be cyanide, though. It could have been some stress throughout the supply chain, or
Yeah.
something else too. So I think we tell ourselves a lot of mind stories about this, right? Because it fits nice and neatly to say that if the fish
Yeah.
was caught with cyanide, that therefore it's going to be permanently damaged, and it's not good for your tank. And so we just don't have a lot of research to back that up we do know it does tremendous damage to the gut, and it kind of looks like it's by about day 50 or so post exposure, you wouldn't be able to necessarily see that indicative damage.
Wow.
We have a bunch of tissues we've saved for histology this last exposure we did,
Yeah.
if we can get around to getting the histology done. But to try to look at that, the work that had been done prior to this, I think, with histology, looking at the liver and the tissues and things, is like 1990s, and techniques have come a long way since then. And
Right.
right, so it would be good to take a kind of a look at this. From a little bit more of a clinical aspect to see what's happening. There just hasn't been a lot of research in this topic at all.
I'm kind of blown away. So you basically
So,
you busted a myth, I think, because
well,
I've heard it so many times
yeah,
that I thought it was
again,
kind of a truism.
I think the truth here is I think this is how people need to think about it. If you're buying fish from a supply chain that is caring for those fish properly through the supply chain and getting it to the store and to you,
Right.
those fish have a very good chance of surviving, right?
Yeah.
And there's some great examples of long supply chains that are done very well, and the fish do extremely well, right? So now, if you're going to say cut corners and not care about the environment or not care about fish or yourself, and you're going
Right.
to you're going to supply fishermen with cyanide, and so you're an exporter and you're knowingly buying these things, or you just don't care enough to find that out, and then you send it through the supply chain,
Yeah.
right? You probably are cutting other corners too,
Mm-hmm.
right? And so I've often argued, and I've had conversations with some Philippine exporters that are, I think, some of the most conscientious exporters in the world when it comes to how they handle their fish and their water quality and their systems and making sure they're not buying cyanide-caught fish, right? I've argued with them that what they need is better standards when it comes to either some regulations, which can be a bad word for some people, or something that requires some technical sophistication
Yeah.
along the lines of exporters, and so they have good equipment and they have knowledge about this, and they have to have some regular inspection, because I think to me there's always been a correlation between importers, exporters who have really good data about where their animals come from, regularly visit the facilities where their animals come from,
Yeah.
track everything they possibly can, and are honest. Those people tend to probably have better supply chains than people who are just selling fish and are, aren't necessarily as concerned about good business practices.
I was going to say skirting the rules. It really comes down to
Yeah.
accountability, and it's something we've kind of been preaching this for like over a decade, that we need more and more accountability within our own industry, not needing the government to create laws to make life harder. Because
Well,
invariably,
I'll be honest with you, Mark. I'll be honest with you. I am not a hopeful person when it comes to getting individuals to be accountable for
I
themselves,
know, I
right?
know, I know.
I think small groups of individuals tend to be will do a good job together. Small groups of
Yeah.
individuals, small communities tend to do a good job self-policing. And once you grow a community, it's a little bit harder. And then I think you have to recognize too that most of the people who have fish aren't watching live streams like this, right? And
Yeah.
so they don't have a lot of knowledge or information about where their fish are coming from. And so
Right.
you need some mechanisms in place to basically set a baseline threshold of right responsibility, right?
Yeah.
Right. And and I think that if that required laws and fish were a little bit more expensive because of that, I don't think that would be a bad thing. And I think we could talk a lot about examples of where we wish we'd have had better regulations sooner. And I think Hawaii is a really good example of that. It would have been nice to have better regulations and not had things happen over there that happened, and end up where we are now. You know, so I would suggest that I know that there's a lot of hobbyists and businesses that really don't want to talk about that regulatory word because they see that as really, right,
Yeah.
don't take my freedoms away. They kind of get confused about,
Yeah.
I think they're, but it, it's going to be hard to get change across the board that's required to ensure that a large industry that is international, spans a lot of countries,
Yeah.
supplies fish to more than the United States,
Yeah.
is somehow going to clean itself up just by goodwill from a small group inside the industry.
Yeah, I mean, my brain goes to like you have a group of people from around the world in a conversation, in a like my Milo's Reef Club Milo's Reef chat. We have this group. It's been going for 4 years. It's got like 10,000 people, and we have a handful of moderators to keep the peace. Kind of need
Yeah,
some moderators for the fish industry, sort of.
yeah.
But
The
like you
challenge is
said, no one wants to be. They don't. Okay, but then I think of, and this is a U.S. thing, and I am not happy about taxes. Okay, but in the United States, we have the IRS, and we have freedom as long as we provide our paperwork at the end of the year. And if it's bad or corrupt and they find out, you go to jail. If you're good, you're freedom for another year. I almost wish we had some kind of a system that would just kind of keep a bird's eye view on everybody. And then, like I said, find the guy with the cyanide and just stop him. Now, do we have a guesstimate of how many fish are caught with cyanide these days, not from the 90s? Is it way better? Is it
Well, yeah, I think
still a
yeah, and
thing?
I get asked that question a lot, and often that question comes when something has happened in the world.
Mm.
And so, does an animal rights activist do they get a paper or story published in National Geographic that says 90% of the fish that are caught in the
Oh, yeah.
aquarium trade are caught with cyanide? When that happens, like that just ties up a few weeks of my life, right? Because people want to know, they want to know,
Yes.
they want a number, like
Right.
where are fish coming from, right?
Right.
And so is it better than it was when it in yes, there's no question about that at all, right? There's no question
Hmm.
that it's better. Is it still a problem? Yes. And then my way of answering that question is how much of a problem it is, because I can't give you a number,
Yeah.
and I think anyone who suggests they can give you a number is lying.
Okay.
Is what number are you um, what number are you gonna say is acceptable to you,
Oh no,
right?
I don't like any
Um,
of it. I want it to stop,
right,
just like shark
right,
finning,
right.
right?
But so
But
so
if you
well,
said
but
it's
but
90% resolved, I feel a little bit better than
yeah.
you're saying
So
it's
I
50% resolved. You know?
well, I think what you have to do is you have to look at the trade as whole. Let's look at the trade as a whole.
Okay.
Um, 80 some percent of our fish come from Indonesia and the Philippines, right?
Okay.
Okay. So in those areas, you
I want to
still
put that on
have
the screen. Is that
certain.
this map right here? I'm going to make it bigger.
Yeah, you can bring that up, and
Okay, guys, I'm going to create
so
something
now
here, so it's going to probably mess things up. Give
now
me a second here.
I am getting old, and so is that data, right? So
Yeah.
um, so I'm getting old, and so is that data, but um, you know, roughly 80% of the fish, 85% of the fish coming in the United States and Europe. Europe buys a little bit more fish from Indonesia than it does the Philippines. The United States buys more fish from the Philippines than it does Indonesia generally. But generally, most of your aquarium fish are coming in from Indonesia and the Philippines.
I see
Those are
that.
the two countries with the biggest use of cyanide. Vietnam has a problem. China has a problem in the southern part of China.
Hmm.
Um, uh, there has been some murmurings about it in a couple other countries, but I haven't seen any evidence of it. Um, um, and then you have, and the reason we color coded the maps the way we did, the red there,
Hmm.
to me is really the jewel of the trade,
Mm.
in many parts, where you have this really neat biodiversity coming out of these very remote islands, that are small scale fisheries, or Australia, right? It's a very well regulated fishery that
Yeah.
has there's very little issues over there. There's some overfishing that had happened in a couple of the islands in the Marshall Islands. Kiribati had, the price of flame angels had gotten too low at one point, and they put some regulations in to fix that.
Mm.
But that red is just a really great. There's a lot of good stories in there about
Hmm.
about supporting sustainable fisheries. Now, there's also some really remarkable stories about supporting fishermen in very rural parts of Indonesia and the Philippines as well. And so, it is, it's tough because you want to support you want to engage people that to support these ecosystems and maintain these ecosystems. Just by keeping fish in your tank or buying aquaculture fish is really not gonna, it doesn't provide as much support to natural reefs as it would if you were buying fish from fisheries where the fishermen were protecting the area, and that
Yeah.
is some of the aquarium fisheries definitely do that.
Yeah.
And those are really valuable fisheries because they're protecting large areas of reef. They tend to keep destructive fishing practices away from those areas, and then
Yeah.
therefore they're probably a pretty net positive to those ecosystems. And then you have highly regulated fisheries, Florida, Hawaii, um, Sri Lanka's actually was highly regulated when they were in a state of war, but just because of de facto getting into the water.
Yeah.
But so there are ways to buy fish where you don't have to worry about cyanide at all,
Mm-hmm.
right? But that's not most of our fish. Most of our fish come from countries where there are some species of fish that are more often targeted with cyanide than others. And then there are regions in those countries where there's more cyanide activity than others.
Okay. All right. Got it.
So is it 15% of the trade? Is it 25%?
We
I
don't
have
know.
honestly,
Right.
yeah, you don't know, and I don't like to give a percentage because you
That's
just
fine.
don't know. And I think
Okay.
yeah, and I think it does the idea of a data point injustice, right?
Yeah, if it's a
Suggest,
guess, then it's no good at all, obviously. If
yeah.
we had this oversight system and we knew there was
Well, the
these
first thing you would have to
specific
have, Mark, is
divers, you
the
know.
first thing you would have to have is a way to actually determine if the fish have been caught with cyanide or not, right?
Okay, that was
Um,
where I was going to
you
go
know,
next. How do you find
we
out if a
could,
fish has cyanide? Because the last I heard, and
yeah.
it was your presentation, I think, you had to put the fish in a blender and then measure the goo to see if anything was present.
Right. So there's the challenge with so IMA, International Marine Life Alliance, Peter Rubrick and a couple other people in the I think the 80s or 90s were doing this test, right? They set this test up for the Philippines. BFAR, I think, still actually does this test where they literally put a fish in a blender, they
Mm-hmm.
blend it up, they take that smoothie, right? And if you're Center Live friends, the Bassomatic, basically, right?
Yep.
So you make a fish smoothie, and then you put that into a flask, and you add acid to that, and you heat
Mm-hmm.
it up, and you basically extract the cyanide out of the sample. Now this works in the lab.
Yeah.
We can take fish that fish smoothie, and we can add cyanide to fish smoothie, and then get cyanide back out. What I have never seen
Mm-hmm.
is someone actually expose fish to cyanide and do that test, and it actually worked.
Oh.
And so there is no evidence that has ever been done.
Okay.
In a right, taking a fish smoothie and adding cyanide is very different than catching a fish with
Of course.
cyanide, blending the fish up with cyanide,
And
and then
proving.
finding the cyanide. Right.
Right.
Now, here's the problem. The fish is going to metabolize that cyanide very, very, very quickly over to
Yeah.
something not toxic. And let me bring up a graphic, and I'll show you how fast this
Okay.
happens. Let's see, which one is it? All
And
right,
then
I'm
I
going
want
to
to talk
guess.
about that study
Um,
that you debunked or talked about also in your MACNA
yeah,
presentation.
sure. All right, so now this is a paper we published. Alex Bonanno published.
Hang
He's the
on,
lead
let me
author
see
of
if I
this.
can.
He was.
Hang on. Let me get
Can
this
you,
on there.
can you see it?
I think we do. Let me shrink you down
Yeah,
and
there we go.
shrink me down and shrink everything down. Get me out of the way. Here, I'm just gonna. I don't know what I'm gonna do. I'm gonna move myself over here. Is that good enough on the screen for y'all? Can we make that? Yeah, I guess that's the best we can do. All right. Yes. Go ahead.
So this is what you would call what we call a graphical abstract. I'm not asking people to read this paper, but they could read the abstract. We had this graphical abstract made, so maybe more people would be able to read it and understand what we were doing. So Alex Bonanno, former student of mine, was working in the lab when we were starting to work on trying to get more data about this. This was funded by Pet Advocacy Network, which used to be called PJAC, which is the lobby group essentially, right, for the pet trade. They've been very interested in generating more data around what's actually happening in the fish, right? And so if you look at the fish, and so if we expose fish to cyanide, right?
Yeah.
And we give them, like I said, when we're giving them so much that they're almost going to die,
Right.
right? And then we take them out of that. The graph here is what you're seeing. You see that up and then the down, right?
Yeah.
Okay. This is the metabolite. So this is this S. So cyanide is carbon and nitrogen, triple bond, carbon, nitrogen, right?
Okay.
It is a very special molecule, right?
Yeah.
And it's very reactive. So it reacts with a lot of things. So SCN is made in the fish from the cyanide, and they add a sulfur to it to detoxify it, right?
Okay.
And you can get a lot of thiocyanate from your food as well. So if you like broccoli and other things, right, has and if you're a smoker, you have a lot of this in your saliva, right? And so the reason is because when we expose the fish to cyanide, it is going to convert that cyanide over to thiocyanate, right? And then you're going to see this peak, right? Now we don't pretend, okay, to actually have caught the fish and bled these fish out exactly when they peaked. Yeah. We're close, right? Yeah. And so we've run a model. I've fitted a model to this, right? And so so you can see that it peaks up and then it comes back down to this baseline level somewhere. And there's a lot of noise in here, and we're finding this baseline is really hard. Right. Okay, figuring out what is this baseline, very, very hard. It gets down to somewhere near zero probably. But it's not easy to get this baseline. But this up and down is actually pretty easy to get, and then you'll see some noise out. You'll see some data points that are a little noisy here and there. That's normal in biology to have that kind of noise. But basically you're seeing this peak. And in Clarkie clownfish, it happens very quick. So somewhere a few hours after exposure, they have peaked. With their conversion rate. It's not that there's still not cyanide in their body. It's still there. It's just they've gotten most of it detoxified, right?
Yeah.
And we have some new data that actually we're going to present in a meeting in Singapore in mid-June, right? Nancy and I are heading to Singapore to present some new data that we got last year with some students that we actually looked at the actual cyanide molecule. Okay. Not the metabolites. We're actually looking at the cyanide, and it comes out very fast. So you've got this very short window of time, and it's going to depend on the fish, the species, right? Because we were working with Ocellaris clownfish for a long time, and I could take you over to that one too.
You've messed up our screen.
So,
oh, here we go. No, we're fine. We're fine. I don't know.
I had it set up so it was similar.
No, you're fine. I'm just going to move you over here so there's two of you.
So you can see the same peak here. It's just not modeled out, but you can see the same peak here. The gray is headed up and then it comes out, right? And
within the 4-hour mark, it looks like.
It's up pretty quick. Now, again, because we just gave you one of the deadliest poisons on Earth and you're paralyzed, and these fish are paralyzed for about 20 minutes or so, 15, 20 minutes. They don't move. And then they're going to detoxify it, and then it gets to something near baseline. Now, that baseline is really hard it's hard to know what that baseline is and get that precise. So people tend to get fixated on lines, right? And so we got a straight line here, and they're gonna right. And so we got really excited when we saw this because we were hoping that this baseline would stay elevated from the controls for a long period of time. But the fish eliminate the cyanide very, very very from their system.
A lot quicker than I expected.
Right? It's toxic. They have to. If they were hanging on to it for a long time. Right. It's and it's bound to some proteins and bound to some other things, but they're getting rid of it as quick as they possibly can. And so you probably we think you've got in the order of a day, right, to do that smoothie test, right? If the smoothie test actually could be validated on fish that had been caught with cyanide. So we and I've been bugging Nancy about doing that, but it's kind of old school chemistry, and she's, it's kind of a, you know, but so we probably have around a day, maybe a day and a half, but probably not that, probably just a
But
day.
and it
So
sounds
we
like
got
you
to,
could only do that test with captive fish you already have that you've infected with the cyanide. You can't bring an imported one because it takes a couple days to
oh,
arrive.
yeah. The idea of testing fish in a country that they come into for these compounds, right, is probably, now again, we got really excited with the Ocellaris, the data I have up here, because we saw this tail, this kind of slow decay, the red line on the graph there,
Yeah.
this slow decay,
Hmm.
right? That it seems like it goes out really quick and then it hits this threshold, and we're trying to figure out what is causing that threshold.
Hmm.
And we speculate all about all kinds of things in this paper. And you're probably wrong about most of them, and maybe one of them we're right about. But
Yeah.
so is that tail real? Is this above the dotted line,
Yeah.
zero or near zero? Is that real? And if there's a differential between never seen cyanide versus seen cyanide,
Yeah.
then maybe you could have a test that would work, right? But I think that's just wishful thinking, right? I think the reality is that if we were set up, say we set up shop in
Hmm.
Indonesia or the Philippines, and we had a test that was really easy to work with, and you could just say pop a cartridge in there and
Yeah.
and on the boat or something, yeah, you can probably start to get to that, right?
Yeah, I was
And
kind of thinking quality control. You just grab one fish out of the fish they brought in at the exporter,
yeah,
like literally came from the
yeah,
fisherman. Like, give me one of those chromis or one of those whatever
yeah,
they
yeah,
caught,
yeah.
and do
That's
the
and
test. But you wouldn't know for sure. But you at least you're kind of ruling out
Yeah, so that's
potentially.
getting it set up that way. That had been my hope for a long time, is that we would get to a point where we could do something in the field over in
Yeah,
Indonesia and the Philippines, right? That's a far better place to work than it is to say try to do it in the United States with
right.
fish that are
Because
imported or
it's
something like that.
because you have them sooner.
Well, and you can fix the problem for more
Yeah,
than just the United States if you could do that, right? So,
right.
and I know a lot of exporters would be very interested in this. Importers would be very interested. Governments would be very interested. The trick is to actualize a test that's reliable. And I think most people now are pretty accustomed to sticking something up their nose, swabbing, and putting it in a thing and getting a line, right?
Yeah,
And it's remarkable how good that line is, right?
yeah,
And that is the quality of type test that you would have to make this. You need something that you
yeah.
you had some you needed some certainty. You wouldn't want to be like, well, is that or isn't that?
Right.
Do I go live in my bedroom for 10 days, or am I okay to go out eat with my friends?
Yeah,
Right? I mean, and so if you're going to develop a test where you're trying to say certify a product or mark a product as clean or make some law enforcement, it has to be really good. And
yeah,
we are in the infancy of understanding what's actually happening in the fish. We don't have a lot of research. The couple papers that we were published are essentially uh, more or less all that's out there within the fish's blood. That's what's actually happening, right? There's just not a ton out there. And you always hope when you start putting papers and publish that you kind of get other people to start publishing and doing work as well.
yeah.
But
Or to disprove
there's
you
not,
one way or another. Yeah,
yeah, to work with it, right? Just work with the data, right?
yeah.
Just keep working with the data, because we've got two species we've published on thiocyanate, which is this graph you're seeing now. We have another data set on cyanide,
Yeah,
and that is essentially the world's data on cyanide in fish,
hmm.
right?
That's it.
That's it.
Yeah.
That's it. And so
And when
and
was that
that's
done?
unfortunate. We did this. So we started working on this. I started. Well, we're doing some molecular stuff as well, looking at gene activity. I started that in 2008. And we started, and we could talk about some of this other work. I came up to New England to take the job up here at Roger Williams in 2008, and immediately started talking to people about, is there something we could do? So we started working on a molecular assay to look at gene response to see
Hmm.
if we could see that proteins and genes and things. And then a paper came out in 2012, right? So a paper came out in 2012, uh, and that to reported to kind of change how the world works when it comes to cyanide testing. And I got really excited about this test. I'm quoted in that article. That's an article in Coral Magazine. I would encourage people to read it. It was
Okay.
written by Rhett. It was really nice to have an investigative reporter, basically, somebody who's really a journalist in, writing about the trade.
Right.
And Rhett's done some really, really good stuff in this area. And so uh, this article came out. The study was published in 2012. I had heard about it in 2009.
Okay.
And I was really excited about it. So I cobbled together some money from a friend of mine. I called a friend of mine who had a small NGO at the time. We'd been doing some work together on the north coast of Bali, and I said, "Can you get me some money?" And I grabbed my analytical chemist friend Nancy Breen here at Roger Williams. She's a really good analytical chemist, and we had been working on fatty acid research and some other things with aquaculture. And I said, "Hey, if I get some money, can you help us with this?" And we got a couple really amazing students to try to replicate that study.
Mm-hmm.
And do what you really do in science, which is can we repeat this data set with a different species? We said, okay, if they did this species, can we do that species? Can we do something different? Same type of test, but maybe with different species. And we spent from 2013, 14, we spent until 2017 trying to replicate it until we realized it wasn't real. And then once we realized that the data was fake, then we were able to come back, and that's when we started testing the fish's blood and actually getting data. So we spent about 3.5 years striking out every day, which is pretty tough to do in the lab. It's and I think this is where people have a kind of a misunderstanding about how science works and what the power of science and why science is such a really powerful tool moving across time. Is other scientists repeating or duplicate, not necessarily duplicating, but working in the same area or doing similar types of work together, all kind of saying the same thing. And so we were really hoping when we started this work that we were going to be able to basically say, well, this is amazing. Right. This is a game changer. And it turned out to be, wow, what a wet noodle. This isn't real. And we didn't know what was going on for a while. We spent several years thinking it was us, right? And then we did some additional work, and then Nancy did the math one day when she was driving to pick her daughter up from college. So like a 7-hour drive, and she just sat down and did the math and waiting for her daughter to finish a final exam, and then she texted me some expletives because she figured out that it wasn't real. So and then I've given several presentations on this right, and you can see those presentations. I think they're usually bulk resupply, or somebody's got them sponsored
from MACNA.
From MACNA, right? And they've made them publicly available, right? And so if people are really interested in the topic, they can read that. The National Geographic had published, Rhett probably covered it or Reef Coral Magazine probably covered it as well, but National Geographic did a big story on it, because they had covered in 2016, they had covered this. They basically said that 90% of the aquarium fish were caught with cyanide. And so I was at a meeting where the editor of the National Geographic was there. They had worked on that story, or she was the author of that story. I think she's an editor now. And I gave her our manuscript, and I said, I think you need to look at this again. I think it's really important that you follow this back up and look at this. So, we're still kind of squabbling and fighting over this, by the way. I just got an email on Friday, I think, from PLOS One, asking some questions about our paper. We've been trying to get that paper retracted for, I don't know, 3, 4, 5 years now, several years.
The fake paper, basically, you're talking about?
Yeah. So, this is where I think the public gets confused about science. So something will get published, and it could just be wrong. Yeah. Right. It could be, and this happens quite a bit, where you publish something and you're like, oh, actually that didn't work and it's not right. Right. It's wrong. And there's several levels of it's wrong. It's not replicable. You can't repeat the data. You made an error, and then all the way to the end of they made something up. Right. And this one is on they made something up. Right. And I think if we go in and we look at the, if you look at the data and you look at it with a critical eye, you can see it in the graphs, right? It's not, there's no way that data is real.
Did you mention this? Well, I'm sorry, because I'm running the show and I'm trying to make sure the screen looks right and I'm tracking all the... Did you mention what the actual test was? Did you specify that in this conversation? Did I hear it and not hear it? Like,
this
The fake test, you know, that they were going to like
yeah,
drop
yeah.
a pill in a bag with a fish and the water's supposed to turn
No,
blue
no,
or
no, no,
something.
no, no. No, it was no, it was really elegant. It was they were looking at the water the fish were being held in, and they were detecting that molecule that we were detecting in the blood, right? The
Oh,
thiocyanate in the water.
okay.
Really elegant, really just beautifully elegant to be able to take a bag of fish, right?
Yeah.
Put it in known water, and then test that water, and be able to clear that fish, a non-destructive test. Just beautifully elegant,
Yeah.
right? The problem is that there's no way the fish can release enough thiocyanate into the water for you to be able to measure it.
Right.
And then that's if they had it in their system,
Yeah.
right? And then they don't, or they, it's not. There's, it's being locked up in their muscle tissue. We don't know exactly where the thiocyanate's going in
Yeah,
the
that's what
fish
I was
after
gonna.
it comes out of their bloodstream.
I was gonna kind of say that. I mean, it may not even show up in the water because if I understood what you said in the beginning part of the show, the cyanide in, at least in a human, I don't know about a fish, but the cyanide in the thing, the body then attacks it and processes it. I mean, obviously at some point it has to export somehow. Fish poop, fish pee, I
Yeah, well,
guess.
humans,
But the
well, so that's actually, yeah, humans actually are pretty simple. We have kidneys, right? Okay, and we pee, right? And things come out
yeah,
that, right? Fish are so much more interesting than humans. Fish have
really,
gills,
tell us
and they
more.
also have right, right. But I think people forget about the gill. The gill in the fish is such a remarkable organ, right? So it controls salt balance in the fish, right? So it controls the osmolarity or the salt concentration, which is about 50% of the salt water in their around them. The fish's salinity is about half what the salinity around them is. So they're regulating the salt balance in and out of them. If you're ever stranded on a dinghy out in the middle of the ocean, you know not to drink salt water because it will dehydrate you.
Right.
But fish have to drink salt water all the time because they're
True.
losing water all the time. And they have mechanisms to excrete all that salt out their gills. They get rid of ammonia out their gills, right? So the
Wow.
ammonia that shows up in your tank is mostly coming out the gills. I tell my students to be like if you were
Wow.
breathing ammonia instead of peeing,
Yeah.
basically, right? So their organ to bring oxygen into their body is getting rid of ions
Yeah.
and excreting all this extra chloride ions and things that from them drinking water, and it's also getting rid of the ammonia and other things too. So it's a lot of things are leaving out their gills. So we thought for a long time, well, that's where the thiocyanete's going. It's going out their gills.
Yeah.
But if you start looking at the numbers of thiocyanate molecules and chloride molecules, and that's why I said we speculated a lot in that first paper
Yeah.
about where it was going. If you start looking at the numbers, it's unlikely that it's actually leaving their gills at any percentage, right? Because it's probably a probability of chloride ions, thiocyanate ions, right? A negative one ion, a negative one charge is probably all leaving out that same pathway. But it's the probability of like 19,000 parts per million chloride ions or whatever it is in their blood, right? Some high level versus a few parts per million of
Right.
thiocyanate. Going to take a long time to get that out. That's probably their muscle tissue is probably a pretty good sink for it. And so we're still doing some work around that. Is their muscle tissue a sink? Does it sit in their muscle tissue for a long time?
Right. And then does it sit
Right.
there, or does it, as they swim, they're working the muscle, it's slinging it somewhere?
No, it's.
I don't know.
The muscles are highly vascularized, right? They have a lot of blood coming. Well, they're not highly vascular. They're vascularized. They have blood coming in and out of them. They're
Okay.
making metabolites and waste products. They're moving that out. All that's
Yeah.
connected in. And so you would see it in the bloodstream, and we're seeing the peak come up
Yeah.
and then go back down in the bloodstream.
In the blood. Yeah.
Right? In the blood. So the blood is hooked to the gills. So if you're going to get it out of it, right, then but marine fish don't pee, right? And I think that people
They
need to
don't
understand
pee?
that too. No, well, they do very.
I know
very well, but
nothing.
think about it.
Nothing.
Think about it. If you are concerned about dehydrating, then you're not going to pee very often, right? And marine fish are really worried about losing water, so they're peeing really concentrated urine. So they're bringing lots of water in. They're losing water out their gills. They're losing ions. They're excreting ions, and they're peeing just a little bit. So that normal pathway that you would think, humans smoke cigarettes, have cyanide in their saliva, piss out thiocyanate, right?
Right.
That's not so simple in marine fish, right? And we just don't understand the mechanisms of retention or elimination out of the fish, really, to I think to have a high level of confidence in what's actually happening. And again, if you want to read some remarkable speculation, you can go to our first paper, and we think. I mean, I got hung up. I think what happens too is you get a little bit hung up about what you've read previous, your kind of previous thoughts, and so we had been trying to replicate this work where they basically were saying the fish is exposed to cyanide, it stays in their system, and they're excreting it out their urine, right? Which is what Peter Rubrick at IMA had been, there was some writings in the 90s about this. And so you read this and you have this in your brain, right? And then you're writing this down. And so you kind of make this link of, well, that must be what's happening. It must be going from the bloodstream out, and then maybe, is it leaving out the urine? Is it leaving out the gills? Where's it leaving? Right. And to be honest with you, we have not conclusively shown that it's actually leaving the fish. And that's something I've wanted to do for some time, is to actually figure out, is it actually leaving the fish?
Yeah, because you said earlier that it breaks down. So if it breaks it down into different elements, those elements can be in the fish body and not be damaging?
Well, we think thiocyanate is really, really stable, right? So thiocyanate is very stable, and it's not metabolized, that I know of, very, very reactively. So it's not a toxic compound. So it's probably not broken down into sulfur, nitrogen, and carbon very, very easily. It probably is residual thiocyanate until it's out into the environment. But again,
still figuring it out.
Yeah. We just don't have an answer to that. So
okay. All right. Well, let's transition. Is there anything else you want to talk about in this specific topic, or did we kind of?
Well, I think to me, what people need to be aware of is that there's still sourcing issues in the trade, right? And they really need to support. They need to support with their dollars, right? If you want to think of a market-driven response, they need to support with the dollars buying wild fish from trade pathways that are known. People who go to the trouble to show you their trade routes, right? To say this fish is coming from this part of the world,
right? And
it's coming we got it here, and now it went there. That traceability, I think, is worth paying for. And so I think that people need to, they need to, right? And if they're concerned about where they're getting their fish from, there's plenty of fish you can buy a lot of fish from areas of the world that don't have cyanide fishing problems, but that doesn't fix the cyanide fishing problems, right? To fix those problems, we need to work in the countries. You need to support groups that are working in Philippines and Indonesia to help fishermen secure net supplies and training fishermen to use nets and buying fish, from supply chains that don't use cyanide. Those are the activities that hobbyists could do that would have the biggest impact on cyanide use. Just saying you're buying all aquaculture fish, or you're only buying fish from Fiji or Hawaii or wherever, is not going to is not going to eliminate the use of cyanide, right? Fishermen would if they're catching food fish for the food trade, they might be using cyanide as well. So just supplanting that activity, just saying we're not going to buy fish from this place anymore, it doesn't solve a problem.
Yeah. Let's see if I can get you back on the screen here. Rearrange things a little bit. All right.
Oh, now it looks like fall back there. That's kind of weird.
That is weird. How'd you do that?
I didn't do that. That's your background. I don't really want to think about fall right now. It just the leaves just came out not too long ago.
We've been talking that long.
Yeah.
Okay, so back to that the map. You had the arrow that was I think it was red.
Yeah, the South Pacific. Yeah.
We have to order from Marshall Islands and from Tonga and from Fiji, and I mean, like you were saying, that was like the ideal group.
This is, the reason I tell people it's really ideal is because those supply chains are shorter, right? You know more about where those fish are coming from, and there is no recorded use of cyanide in those areas, and so I think the short supply chain part of that is really good. But again, I don't want to tell people that they shouldn't support fishermen in Indonesia or the Philippines, because
Yeah.
that's just not, it's not the answer to say that, oh, we're just going to shut that off and not
Right.
do that anymore.
Yeah.
Because it would be great if you could just turn the tap and like shut the valve, right? Just close the valve and the problem goes away.
Right.
The reality is that that doesn't make problems go away. To make problems go away takes a lot of hard work, and it takes it takes a lot of effort to reform not just this industry, but the live food fish industry, and other fishing industry, other parts of fishing. And so if you can provide a livelihood to folks in Indonesia and the Philippines that is where they're able to comfortably feed their family and educate their kids, I think that is something to be proud of if you can do that, right? But if you're buying from a supply chain that is really taking advantage of people, right? And I think that's how you should look at it. If you should never think of this as simple as fishermen bad, cyanide fishermen bad, right? It's not. That's not how it works. Fishermen generally are really great people that love being on the water, and they know a lot about their environment. They have been, they have middlemen and exporters that really are putting the pressure on them for cheap fish.
Yeah.
And cheap fish is the problem. It's not fishermen, right? Fishermen are a remarkable group of people that are responding to the market, and the market is demanding cheap fish, right?
Which is kind of crazy because, I mean, and this is Hawaii, so it doesn't really count, but I like the Achilles tang. I paid $300 for mine, and it was the smallest one I could find. It was the best deal I could find. The other one I was gonna get from a place that quarantines their fish was $450, and yet in Hawaii they eat Achilles, and I think it's like, I don't know, 5 fish per pound or something, and it's $5 a pound.
I've seen them at the grocery stores in Maui. There's a lot of orange shoulder tanks and Achilles and things for sale. So, but is one more valuable than the other in a supermarket or your fish tank? And I use that example actually, like which is a is it an object problem to have them collected for people's fish tanks or to be on ice at a grocery store? Those are. But it's not necessarily a bad thing to eat tangs. I mean, my favorite fish to eat when I'm in Indonesia is a unicorn tang, and they're delicious, and I
do you eat the horn too? What's wrong with you?
I go to this little island, and they spearfish them and they grill them with coconut, and they are just spectacular, right? But the Tang police will probably get me for that. But
well, I'm thinking, because I'm anti-freshwater. Everyone knows that. I make fun of it all the time. So we can eat all the freshwater fish we want. Leave the ocean fish alone.
Don't eat freshwater fish. They're not very good. So I think it's. I don't think it's worth putting. I think to me that illustrative example of you have 100 times more biomass on ice sold to be eaten than you do in an aquarium trade. Right. That's just illustrative. That's illustrative of public advocacy and activism being very effective, and science not being very effective. Right. No. That's what that is.
So how can we support a sustainable fishery if we don't know where they're getting the fish from?
Well, I think you have to support. I think it's worthy to support. There are places you're getting your fish from, right? You can go online or go to stores and ask them if they can trace their fish. There are groups out there. I used to have an online e-tailer before they went down the tubes that I would tell people to go to, because I knew they were getting really high quality traceable fish. But but you can there are places online, there are wholesalers that do a really good job with this. You just have to ask questions, and if they tell you it's a secret, right? If their supply is a secret, that's I've always loved that one, because there's very few secrets out there in this industry. Even when there are secrets. Yeah, and you'll notice this with corals. There's a lot of those secret corals. A lot of those, a lot of them aren't legal. Secrets are always interesting. But I would say if people are interested in supporting this, they can pay more money for fish that are traceable. But to be honest with you, and people aren't going to like this at all, it's going to take legislation to require traceability for it to happen, right?
Yeah.
It's going to. There's too much money to be made by people out there undercutting things, and you saw this with. I love this, and I can't remember exactly when what. So it was the hippo tang when University of Florida first raised the hippo tang. Like instantly on social media, like it might have taken them a few hours to take a Sharpie and write tank bred or whatever and float it in a styrofoam thing and float it in their tank. And a wholesaler out there, a very unscrupulous individual, wrote that on there, floated it and took a picture and put it on social media. Right. Those are the people you don't want to support, right?
Yeah.
You don't want to support people that are willing to flash up marketing like that around an event and confuse people and be shady about their activities. And there's plenty of them out there. So that's the problem is that you have people that are cheating taxes and cheating all kinds of regulations, cheating all kinds of things.
Right.
And if they're going to cheat that stuff, they're probably cheating the quality of their fish. And so they're in the same marketplace as someone who is spending extra money having traceability. These two people are selling the same fish. They come into a store and you don't know for about 2 weeks to a month which one's better, right? And so that's part of the challenge.
I feel like you told me nothing. So, I mean, I've had experiences in the past where I went to a fish store and I bought fish and bought fish and bought fish, and the fish kept dying. And I said, I'll stop buying from that store. Still don't know where they came from. Still don't know why they were dying.
Well, I mean, we brought in 100 wild ocellaris a couple months ago. We've got a grant to work on looking at deformities and a few other things and production performance in clownfish, right? Arguably the most important aquaculture fish in the trade because of the number of fish that are cultured and sold every year. I'm back in the fall.
I know.
So pretty high mortality rate after I got them, and I knew exactly where they came from. They had to go get them for me because they don't normally collect that fish anymore because they're all cultured basically. And it took several months to get that order set up. And it was all from a parasite that's pretty common, Uranema-like organism, right?
Yeah.
It's probably not Uranema, but had nothing to do with the supply, nothing to do with the way they were collected, everything to do probably with the stress or the route they came into. And we know those fish were collected properly. So, but we still had lost more than we would have liked to. Because of a parasite that we were actively ready for and treating for, right? Yeah. And so, and that happens in a lot of the fish. The chromis and anthias are also susceptible to this. So it's not all about illegal collecting or destructive fishing methods. It's also about handling and facilities having Uranema and other things inherent that they need to be able to monitor and things. So it's a complicated. I mean, think about it. You're bringing a fish from I've got 1% battery left, so I'm gonna go grab my charger. You're bringing fish from the other side of the world. I'll be right back.
Okay.
You're bringing fish from the other side of the world. They've been on a plane for a long time, and you put them in your little reef ecosystem in the United States. That's a long journey, right? And it's complicated. It's not easy to ship fish 40 hours in a bag. And so it requires a fairly good level of sophistication to do that. And maybe that's the reason I'm in the fall. It's because that was my battery going down.
Let me try this. Maybe that'll help. Nope, still. I think it's because you shared your desktop or something, and now we can't get out of that mode. That's my guess. Because the preview is green, but then I put you on split screen, and it's fall. It's the weirdest. You must be in Australia.
So I think that's that's the challenge is there's lots of things happening, right? And I think if you wanted to say, how do you make sure you buy fish that are going to be as healthy as possible, and you're going to make it, I think you want to support a local fish store if you have a good one near you, or an online vendor if you don't have a good local fish store near you, that acclimates their fish, has their fish for a little while. You spend that extra money. You said you could have bought one that's more expensive, but you're very used to acclimating. And if you're not used to acclimating and quarantining fish, and you
Right.
have a store that you could pay to do that, that is well spent dollars,
Yeah.
right? Because I've had fish. Some of my fish I've had I've got a pair of clownfish now of 20, 25 years. And, I've had fish that are just get geriatric and, like they get really old. And if you're taking really great care of your fish, they're going to live a really long time, right?
Yeah.
Much longer than they would ever live in the wild,
Yeah.
right?
Yeah.
So if you look at it as from a cost perspective and you say, wow, that seems like an expensive fish,
Mm-hmm.
it really is not very expensive compared to what else you got going on in that tank, right?
Yeah. Yeah.
Your power bill probably is more expensive, than that fish is, right? So I think the notion that I think what happens is people are like, well, that one's $65 and that one's $99 and that one's $150. Like it's the same, has the same name on it. So which one's better, right? And so I think that's where it comes down to. I think from my perspective of looking at data for the last 15 years or so on the trade and I would like to see fishermen make more money for their fish, a lot more money. I would like to see I'd like to see the exporters spend a little bit more time and not be concerned about the margins as much because they're making a little bit more money. I'd like to see the importers making a little bit more money per fish, and then the number of fish come down a little bit, because I think that would long term, I think it would be good for everybody that if they had a little higher quality fish out there. When I was working in a fish store, when I was an undergraduate, I worked in a pet store, and I remember buying Bill Addison's clownfish the first time, right? And we went from having wild Ocellaris to aquaculture clownfish in 1996, 7, somewhere in there. I can't remember exactly when, but people's success rate went through the roof because they had fish that would eat out of your hand. And so, I think that's just what people should focus on is, I'm back.
I figured it
people
out.
Should focus, yeah. People should focus on the best quality fish they can possibly buy. Right?
No, I agree. When I go shopping for fish, normally I look at it, I see if it's swimming, I see if it's eating, and I don't see any weird diseases or I don't see any destruction of the fish, then I'm like, okay, that's a good fish. But, there are certain ones that are really tricky. Anthias are not easy. Flame angels, I find, are very difficult. I have this weird rule I created a long time ago. You get a flame angel, it has to live 48 hours, then it has to live 14 days, then it has to live 2 months. And if you can get past those 3 thresholds, you'll keep that fish forever. I don't know why I came up with that, but somehow I came up with that crazy timeline.
Yeah, I think if you look at flame angels, are a good example. So Kiribati, it's Christmas Island. It's a fairly big island. Fish in a fairly local area where they're catching most of those flame angels. Really big atoll, right? Fish in a fairly small area. They were catching too many flame angels because the price went down by half. So they're catching twice as many fish for half as much money. So they're making the same amount of money doing twice as much work. And there's all kinds of issues with that, right? So they got in and they reduced the number of fish, but there's only so many boxes that can leave that airport to go through, and right. So there's only so much volume that can come out of those countries because of freight space, and so the bag size, who you're getting them from, how long they have been in tanks, where they have been, how much they've eaten, all these things add up. And then what kind of tank do you have, and are they eating really good food when you get them, and your ability to keep them. And so I think you see that in fish that kind of, you're right, they do all right for a while and then they don't, right? And that's probably evident. I was always surprised when I was working in the aquarium store, how remarkably great yellow tangs did compared to, say, some other tangs that were coming out. So yellow tangs from Hawaii, almost completely bulletproof, never had a problem at all. And then we would get tangs from longer supply chains, brown Scopus tang, almost the same type of fish, not quite as hardy, right, as a yellow tang. Basically, those are the same fish.
Yeah.
Right. And I think that's an indication of distance of travel, collection method, number of people that are
Handling.
handling those
Yeah.
yeah, those sorts of things.
Yeah. Huh. Interesting. Yeah, I mean, I remember losing one flame angel years ago. It was something as simple as it was swimming, it was eating. I went to dinner and came home and it was dead. I'm like, what happened in those 2 hours? And so my brain says, oh, it must have been caught with cyanide. That was it. It was about to happen.
Very unlikely, almost impossible for that fish, right? Because where they're coming from, right? They're coming from places that don't have a history. I'm not sure if there were any flame angels coming out of the Philippines or not, right?
Mm-hmm.
But unlikely. More likely, either some type of internal parasite, or some type of chronic stressor that just kind of tripped the balance, right? Or,
Right.
but yeah, people do. The person that contacted me, again, I think people suspect, oh, that fish something must have been wrong with that fish, right?
Yeah.
And I think that's one of the challenges with fish that are swimming in pet stores is that they're supposed to be alive because they're for an aquarium, right? They're not filleted in the grocery store on ice, right?
Oh.
But so now there's different states of alive, right? And is it thriving? Is it doing really well, or is it just persisting? Fish are very good. They're like cats. They're really good at persisting until, we recently had a cat that had cancer for a while. And we had no idea, right?
Mm-hmm.
Because they're very good at hiding that, right?
Yeah.
Wild animals tend to be very, very good at hiding things. So I think that's part of the challenge when you're trying to purchase animals is to make sure that you're doing a good job buying them, and because you want the fish to live as long as it can, and hopefully a ripe old age, because a lot of effort to go in, and then I remind people that every time you introduce a new animal to your tank, you're introducing potential of bringing parasites in. We just brought these new fish into the lab.
Yeah.
We try not to bring a lot of fish into our lab very often because we quarantine them really robustly, but still it's nerve-wracking to bring new animals into a facility that has, that doesn't have any of these diseases yet.
Right. How long is your quarantine?
Yet. About a month and a half.
Okay. 45 days?
Yeah, somewhere in that range. Depends on the fish, right? Sometimes it's 3 weeks. Sometimes it's a month and a half. Depends on where the fish came from and what the fish is. But we do the bucket transfer method basically for that every single day for that, right?
Wow.
Yes. Yep.
It's a lot.
Yeah.
All right.
It is.
Wait,
So.
I want to thank you, Andrew. I was super pleased when you offered to come on the channel. I was like, wow, I got a Macna speaker on here. This is amazing. Like you're this god.
I had given this talk, and I remember you had commented like after the talk or something like that, right? About, I think it was on this topic probably, right? About sourcing or something. But I love this topic. I've been working on it for a long time. I'm always happy to talk about it. And Zoom or these online things make it so much easier to talk to a large group of people. And people are often confused, and it's often counterintuitive. People are really excited about the fact that they can grow corals in their basement, but they want to make assumptions that they're somehow saving coral reefs, but they're not, right? But they have a lot of beautiful corals in their basement, right? And so, but they're definitely not saving coral reefs with their cultures in their basement, or they're selling cultured, right? But
not if you're hoarding them.
Those are the right.
If you're hoarding them, if you're keeping them, they're not helping the reef.
even if you're selling them, if you're growing them yourself, you're not helping the reef. But it doesn't mean that you're not doing you don't have a great hobby, and you're not learning a lot, and you're not doing something really special. It just it takes a lot to be able to actually impact an environment positively, and I love these conversations because hobbyists are really passionate about this stuff. And
absolutely. And I know what you're saying about how it doesn't help the reef. The only argument or counterpoint I could say is that you're not taking from the reef because you're getting frags from a friend in an aquarium. But we are not replanting reefs. We're not lowering the temperature of the water in the ocean. We're not stopping the runoff from the companies, and the industries.
I'm a big fan of Terry Hughes's view on this. There's trillions of coral. There's a trillion corals, or 100 billion corals, or something like that on the Great Barrier Reef. You're gonna plant what, 10,000, right? So from a standpoint that nothing will touch the fact that we're gonna boil these things, that we're the frog in the warm pot, right? That's coral reefs, right? And Indonesia, for example, is growing corals. Wild corals are going to no longer be a thing in Indonesia here in a couple. Like they're gonna zero out wild quota. It's gone. right? I think next year. I think it's 2024. There will be no more wild quota.
What does that mean?
So no no animal, no corals. They're not going to allow the export of CITES listed corals that are wild.
Okay. So only things they
And
grew on racks, like on these beds in the ocean, maybe?
yeah,
Frags.
yeah, yeah,
Oh,
yeah. I'm
okay.
headed. So I have to go to this meeting. I'm going to a coral reef meeting in Singapore in mid-June, and I'm going to stop in Jakarta on the way there and go see a coral farm. I've written several papers. I'm giving a presentation or a
They
poster over
pay
there
you
about
to do this? That's
coral.
amazing. I want to get paid to
No,
do
no, no.
that.
They don't pay. They don't pay you to do this. I pay to go do this. The
Oh,
scientists don't get paid for this stuff. Yeah, we
I was just
pay
going
to
to
do
say,
that, right? So
wow.
yeah, yeah. No, no, no. So that people are confused. They think we get paid for this. No, we actually pay to do that. So
Wow.
but but yeah, the coral farms over there are amazing, right? They really are. It's industrial coral production that
Yeah.
scale is hard to fathom. But
Right.
you know, but when I come back from that, I can talk more about
I'd love that.
you know, coral mariculture and coral culture and
Bring
how
pictures.
disconnected. Yeah, yeah. I'll take some pictures.
No, that'd be great. I'd love to have you back on. We could talk about that. That'd be fantastic.
Yeah.
I did Coral Restoration Foundation in Florida once, and we were all told how to do it. We went through a whole orientation, and then we all dove down, and I was working next to Julian Sprung, the Julian Sprung, and I
Yeah,
was
yeah.
planting. I would hand him like the fishing line, and then he would tie it to the coral under the ocean. We're blowing bubbles, and then they said, okay, put everything in a basket. We're going to this other spot. We get back on the boat. We go over there. We go back down in a new spot. Here's your putty. It's got to be anchored in 3 places. And you got to scrape off the rocks. There's no algae, so it'll hold. And so you're doing this intense work, planting corals on the reef. And it's, 45 minutes underwater. And when I was done with my, 8 pieces, I swam away. And I turned around to go back and see what I just done. And I could barely tell I put anything on the bottom of the ocean. It was just like, a few frags.
What was remarkable about that though is that you can get you can get corals back into areas where they were not, and that has a positive impact, regardless whether it does globally. That has a positive impact, and there's been some real efforts in Indonesia to do this at an industrial scale. Not you're having a good time helping, not. I'm talking about factory level, kilometers of this
Wow.
happen, right? And
Nice.
they can actually make reefs again.
Oh, that's
and
awesome.
And because the Indonesian corals actually grow, where the Caribbean corals are just kind of
Yeah.
But so, but these things have local impacts that are very positive, and that's something that hobbyists could do if they supported restoration or something like that. That supports those local reefs. Same thing with catching lionfish off the reefs. It supports a local, it supports a local area fairly well, right? And that does something positive locally. But that's not going to change the global outlook. And so, but those are complicated topics. So.
Well, thank you so much. I'm going to go ahead and wrap up our show now, and
Sure.
you can literally just walk off camera if you want, or you can stay. It's whatever you want to do. I'm just going to change the screen. You're just going to be in the background.
I've got a lot of yard work to do. So.
All right. Well, thank you so much for coming on. And
have a great
this
day.
video will become permanent, and then there will be questions probably typed underneath. If you happen to see it on YouTube, you're welcome to reply. And don't forget, I need to get a hold of you for Jason Langer. So let's not forget that.
Absolutely.
See, you already forgot.
Yep.
But thank you so much for being here and for telling us about the stuff that we really know nothing about.
Thanks for having me.
All right, bye.
Bye-bye.
Okay, so he is sneaking away. We're going to wrap up the show. Miliv's Reef is my company. I sell coral. I'm sorry, I sell corals. I sell no corals. I sell dry goods. I sell aquarium supplies. If there are things you need for your aquarium and they're in my shop and you buy them, you help support me and allows me to continue to do the things I do, including the YouTube live streams. So I do appreciate your business, and I feel like a lot of my customers do come from YouTube. So I thank you, YouTubers, for being willing to do that for me, because I know you have lots of options, and some are cheaper or some are easier or some are faster. Like Amazon, I get it. But I do carry a lot of different products, from lighting to pumps to food to test kits and everything in between. I have it. So if you need something, go to milivsreef.com and please buy something. Now, every single weekend I encourage you to test your water. I call it Water Test Saturday. Caitlin said the phrase, water tests save lives, and that's why that is on the screen. And it's absolutely true, because like Andrew was just saying a few minutes ago, the corals can, the fish can hide what's going on with them. They could just be sustaining themselves. They could just be getting by. But we want them to thrive. We want them to be colorful and vivid. We want them to be healthy. And the cleaner and better your water is, the more likely that fish will thrive. So if we are checking all the things, which would be alkalinity and calcium and magnesium and nitrate and phosphate and temperature and pH and salinity, I mean, those are the basics. And then from time to time, sending off a test for ICP to see the trace elements and the major elements, make sure your tests are telling you the truth, that would be smart to do. And I do it more frequently than many of you do, but if you do it once or twice a year, matter of fact, if your tank is doing perfectly right now, I would recommend you send up an ICP test right now with that water sample so you've got like a baseline. And that way, when something's going wrong with your tank and you send up another test, you could compare them side by side and say, oh, I see where I'm lacking. This makes absolute sense. I get it. I totally forgot to care about XYZ. So water testing is critical. It should not be a challenge or a thing you don't want to do, because when you bought the tank, you knew you were going to have to do this. And if you are testing your water weekly, odds are things will not get away from you. If you are doing it sporadically or occasionally or almost never, and then something really goes badly and you break out all these test kits, are they even still valid? Are they still giving you the right information because they're old and unused? A new test kit lasts a year from the point of opening. So write the date on the top of the box, and after a year, hopefully it's empty and you need new test kits. And I sell test kits, so you could buy some. I do want you to have really beautiful reefs. I appreciate it when you guys come and share your tank in Club Mueller's Reef on Facebook. That is our group. It's our official group, and it's been around for over 4 years. And if you are not a member yet, and a lot of people will come in and say, I've been watching Mark for years, I'm finally joining the group. Well, do join us, because we have a great friendly group. We answer questions, we show ideas, we help one another, we just look at eye candy. It's a great group to be. So I hope you enjoyed this one. I've got a plan for next Saturday too, another guest, and it'll be a really good topic that I think many of you will be interested in. So enjoy the rest of your weekend, enjoy your holiday weekend, and I will see you again next Saturday. Bye.